Alright, so points, lines, and planes. What I'll do with these things, like I said, I've got this blank one here, and we'll go through and I'll read it off, and then I'll try to give you some examples on this stuff too as we're doing it. So these are your basic definitions for geometry, and everything that we do, oddly enough, is built on these definitions. So, got to get to know these things really good, what they mean, what they're telling you. So here we go. A point is a location. Okay. It just says here we are. This is what you're working with, and it has no size or shape. All right. So if you look in Euclid's Elements, it actually says width or breadth. All right. So that's in thousands of years, it's not really changed that much. So whenever we name a point, or you're reading something on a paper, and it says we always use a capital letter to name a point. Like here's your example right here. This is red point A. So always a capital letter. If you use a lowercase letter, you're actually using a variable. Okay, so whenever we're talking about a point, we're going to use a capital letter. So a natural extension of what a point is, a line is made up of 2 points. All right, so a line is made up of points. Any 2 points form a line. So that's all we need to be able to name a line and say, here you go. Here we go. A line has no thickness to it or width. Now there's a reason.
Pardon the interruption. This time, all seniors, please report to the auditorium.
On these definitions on this thing, the reason why that goes point. Yes, ma'am. Okay. Go. Sorry. All right. So the reason why it's pointing out and saying this, it has size or shape, or it has no thickness or width or anything like that, because that's more of a philosophical debate than it is anything else. So, because you can make the argument that these things don't exist, so what's the point of learning them? But in math, what we're doing is just trying to talk about how to name and look at everyday objects. Okay, so we have to have these idea of a point and a line to be able to apply theorems to them and use them. So we name a line by any 2 points on the line or a lowercase script letter. Generally what we're going to do is, when I talk about a line, we're going to do this. All right, so this is a line N, okay, and it's made up of the 2 points X and Y. So I write my 2 points in capital letters, and then I draw a line over the top of it. So here are my letters, and then just a line over top of X, Y like that. And it's important that you use these arrows to indicate that you're doing a line. If you don't have those arrows, you're actually talking about something else that we'll get to next section. All right? Or you can say, like, use this lowercase letter here, line N. Or you can even write out line X, Y. But it has to absolutely be clear that you're talking about a line, because if you write just an X and a Y, then somebody might think you're talking about multiplying an X and a Y together. You've got to be precise whenever you write these. So collinear are points that lie on the same line. So here X and Y are on the same line, and then some of these questions are going to ask you for non-collinear points. And those are points that do not lie on the same line. Right, so a plane. A plane is a flat surface made up of points. And to name a plane, we have to have at least 3 points. So any 3 points make up a plane. You will already have an idea of what all of this stuff is anyway. So a plane is something like this sheet of paper, okay? This makes a plane. The floor is a plane. The wall is a plane. The ceiling is a plane. So you already have an intuitive idea of what each one of these things mean, because that's the world that you've lived in and that's what you're used to doing already. The only thing different that we are doing is we're making the language that you talk about it in a little bit more precise. Okay? And then with this precision of your language comes, and really good definition, comes being able to predict different things about these things. So we'll get into if-then statements. And they really lead to things that you couldn't have, like things that aren't intuitive to you. With logic, you can just make these leaps and follow this logic trail to stuff that's really weird sometimes, but yet it's still true. So we name a plane by any 3 non-collinear points, or an uppercase script letter. So this right here, that is your script letter that it's talking about. So you can call it plane P, and it's really hard to draw a script letter. I can't do it. Maybe you're more artistic than I am, but I am not very good at that. So whenever I name a plane, I usually just use 3 points. So we can call this KJL. Plane KJL. Or you can call it LJK, JKL, whatever you want to. Some permutation of 3 non-collinear points. So if you talk about coplanar points, they're points that lie on the same plane. Right? And non-coplanar points don't lie on the same plane. Anybody got any questions? You need a second to get caught up with your notes? Alright, so if we have intersecting lines or planes, if you've got 2 lines and they intersect, then they will always intersect at a point. Okay? So this line R and line S are intersecting at point P. So 2 planes intersect at a, what do you think it's going to be? Just a guess or a conjecture. Line. All right, so planes intersect at a line. Right, so now we've got all these definitions and so forth, and this is where it's really important that you take good notes and that you write this stuff down, because the questions that you're going to be asked on, like this practice thing, this is where it'll go. I'll give you notes and then we'll practice some together, and then that homework sheet is whenever I turn you loose and say you do it on your own or with your buddy or something. So it's important that you write down your notes. That way, if you don't remember something on this part or on your homework, you've got something to refer back to. Okay? So we want to read the instructions first on all of these things whenever you're doing them. Use the diagram to the right to name the following. So this is our diagram. We want 4 collinear points. So what does collinear mean again? Same line. So I need 4 points that lie on the same line. Can somebody name me 4 points that lie on the same line? I, K, N, and H. Good. So I, K, N, and H. Alright, so that's not the only 4, are there? Are there any more? 2, 3, 1, 2, 3. Nope, that looks like it. So now we want to name a line that contains point M. So which line contains point M? Line P. So this is what we're going to do. Line P. Alright, what's another way that I can name line P? Can I do this? Can I call it MN? Is that a line that contains that point? Right. So what about MO? You can call it line MO as well. As long as it's got that point in there, you're good to go.
So you don't have to put all 3 points in there?
No, you don't have to put all 3 points on there.
Can you though?
You can, yeah. So a line that contains points H and K. So H is here, K is here. So what's the name of this line? R. Line R. And you can call it HN, HK. Could we call it HI? Yeah, because HI is going through K. It's not explicitly stated that K is in there, but if somebody were to look at it and say, well, does HI contain K? Yeah, so you're still good to go with that one. Another name for line Q. So on here, let's find Q. There it is. What's another way to name this line? Say again? JK. Not just kidding, but JK. Carson, can you name me another, or give me another way to name that line?
Talking about D.
This line right here?
I mean, the question D.
Yeah.
J and K.
J
Wait,
and K.
L.
We already got that
K
one.
and L.
K and L,
My
yeah.
bad. See that?
K and L. And then what else we got? I think we got one more option. JL. Alright, so does it matter which direction these things are going? Is KJ and JK the same line? So JL and LJ are the same line. Alright, so remember that difference on lines, and then whenever we get to start talking about rays, right? Because depending on what you're talking about here is depending on how you can name them. Okay, so we'll get into that, into rays, a little bit later. So the intersection of lines P and R. So where's P? Here, and then R is here, so that means they're going to intersect right there at point N. We'll call it N. All right. So number 2, use the diagram to name the following. So this is starting to get now into the thing that kind of messes people up a little bit. Right? Part of the problem with geometry is that the later we get on, you look at this figure here of this plane, what we try to do is talk about a 3-dimensional object. We give you a picture of a 3-dimensional object on a 2D surface. Okay, so that does tricks with your eyes, right? Some of these things I look at and I'm like, well, which way is going which way? Like, especially when we start looking at pictures of planes that have been put together, it gets really weird sometimes trying to figure out what's going where. The questions aren't hard. It's looking at the picture and figuring out what's what is the difficult thing, and it just takes practice doing that. So that's what we'll try to hopefully be able to do a lot. Is get a lot of practice looking at these, but don't give up on it. It's frustrating sometimes, I'll give you that, but you can do it. So we want to look at this and use the diagram to the right to name the following. So this stuff right here. We want a line containing point F. All right. So here's point F. What's the name of this line? Say again? J. Lowercase j. Sorry. All right, so what is another name for line K? And get in this habit too, whenever you see those. Taught it last semester, and it didn't happen a lot. But sometimes people didn't want to look at the picture. They just wanted to try to answer these without any reference for anything. So always look at your pictures on this stuff. Another name for line K. Here's K. So what can we call this line? I need 2 points on it. B and C. Can I call it B and E?
Yeah.
What about FB? Can I name it FB? Why not?
Because F is a whole.
They have to be on the same line. Now, can I call it EC? All right. All right, so a plane containing point A. So here's the tricky part. Where's the plane at? This right here. And remember, you can name a plane by uppercase letter, or you can give me 3 points to name a plane. What do you want to call this plane? M. Good. And then what about, can I call it ADE? If I could write. That's 3 points in a plane, isn't it? ADE. What about BEF? No, why not? Not on the plane. Non-coplanar points. All right, so give me an example of 3 non-collinear points. So I want 3 points that aren't on the same line. You say DEA? Yep. So DEA is 1, or 3 points. And then we can do B, E, and B as well. Because B is way up here, it's not even close to the same plane. Wait, sorry. Non-collinear points. 3 I was thinking coplanar. But D, E, and B are non-collinear as well. Alright, so the intersection of plane M and line K, what are we going to call it? So plane M and line K. E, point E. Alright, so you all do number 3 and 4 for the time being, and then we'll check and see what you got.